Once again, thanks very much for joining. I'm going to keep an eye on the room list and let people in as they arrive. It's a lovely sunny afternoon here in the UK, so I can understand why. If it's the same in the rest of Europe, I can understand why people are enjoying the garden rather than watching me. This afternoon, we're going to talk about the Backhaul products. A couple of messages on chats. Okay. Apparently, it's a public holiday in Finland, so we've lost some of our Finnish customers. Thank you, Petri. So I really should check these things when I set the schedules. It's very difficult to keep track of public holidays everywhere in the world. So we're going to talk about the Backhaul products, Mimosa's Backhaul products today. We've got two different levels, two different grades of products, for want of a better description. What we call our business grade, our B series backhauls, which are designed to be high capacity, high resilience solutions, designed very much for lease line replacement. And we've also got a lower level of products in terms of speed and functionality, our enterprise access. And if you were on last week's session, the enterprise products, you'll recognize them. You've seen them before. Basically, for the lower end products, we utilize our point to multi-point client products in a point-to-point mode, and that's available as standard for the products. It's not an extra. It's not an extra license. We just toy with the idea of doing that when we launched C5X, but it was awkward to administer, and it really wasn't worth doing. So we stopped that idea. So what are you going to use Backhaul products for? The obvious one, because we're a radio company, because we produce systems for wireless ISPs, for bringing lots of clients in, is to provide the aggregation services for fixed wireless broadband. So connecting the cellular tower in, connecting the tower in that's running multiple customers, into bringing those in and bringing that tower off to a fiber feed somewhere else, or a fiber uplink to the internet, to give you that connectivity. And it's acting like the motorway in the network. If the connections from the clients to the tower are the minor roads, the backhaul is the motorway to get to the city that is the internet. We use them in smart city connectivity for CCTV and bringing in Wi-Fi hotspots, again, as a concatenation service. For lease line replacement, for connecting data centers on a campus to the other buildings, so that everybody can get to central resources. Years ago, I was involved with a company that did a lot of work for the BBC. They were a graphics company called Framestore. Now, they produced a lot of computer animation. They were actually the guys that did the Walking with Dinosaur series for the BBC. So they're doing a lot of rendering and a lot of data work in their data center. As a company, they were very successful, and they found they needed to expand, and they expanded into a building on the other side of the road, with what they thought was the simple idea of connect the two buildings together. They went to the local PTT, British Telecom, and asked them for a fibre dig. They got a quote for the fibre dig, and when they got the quote, they kind of fell off their seats, as it was obscenely expensive. The cost of putting a link in across a major road in London with the associated digging costs, etc., were just huge. So they came to us asking for high capacity wireless solution, and we provided it. And the system worked very well. So in a previous life, I've transported dinosaurs across wireless. That's an unusual application. So that gives you the idea of the sort of things you can do. So for these high capacity installations, what products do we have? I shall show you. So here, this is the B series. These are the Mimosa B series products, starting with B5 and B5C. Now, going back to something we discussed last week, our naming conventions make life very easy. B5 is a backhaul radio in 5 gigahertz. B5C is a backhaul radio in 5 gigahertz with connectors on. They're effectively the same product. There's a couple of small differences, or one small difference between the two. B5 is an integrated radio, so it has its own built-in antenna. And this is B5, not the smallest of radios. This is a 25 dBi built-in antenna. Distance on this with a reasonable data rate, about 10 kilometers. Obviously, as I've said before, with all of these, that's in clear air. If you get interference, that the data rates will drop. It's all about modulation levels and signal over noise. But as a rough rule of thumb, 10 kilometers is achievable with B5. If you need to go a little bit further, then basically you need a bigger antenna. So this is where B5C comes in. So this is a B5 radio, and instead of the built-in antenna, it's got connectors. And I thought I had one here. I always forget to pick at least one up. So this is B5C. Solid unit, fixes onto a pole using Jubilee clips, and underneath we have Ethernet port under here. Nice IP65 gland, air pressure window, and 2 N-type antenna ports. So this radio here is going to give us the same sort of functionality as B5, but you're going to add a different antenna. So when B5 stops at 25 dB, you can maybe want to put a 32 dB or a 40 dB antenna on this, larger and larger. You're looking at antennas for B5C. The main thing to look out for, this is a Ageris 24, is you need dual input. You need dual polarization, because this is what gives us the MIMO. This is what gives us the advantage. So this will transmit in vertical and horizontal polarization in the same dish. And this is the sort of thing you need to look for in a dish for B5C. One other little difference between B5 and B5C is the frequency range supported. If you need to go outside of the core 5 gigahertz band, you'll notice that the B5C has a slightly wider frequency range it operates in. It's a slightly different chipset. So it goes from 4.9 to 6.2, where the B5 is stat in the core 5 gig band. So there are our 5 gigahertz unlicensed radios. We also have B11, which is licensed in most areas. That is a traditional slip fit radio. It looks like a frequency division microwave. It's a direct fit to the back of the antenna. There's a range of antennas that will support 11 gig. Again, Durus, Radio Waves, people like that make 11 gig antennas that are compatible with B11. If you need a list, need some recommended, don't hesitate to drop us a line and we can recommend some antennas. B11 is designed for much, much longer distances. We use these at 50, 60, 70K. In the States, it's a coordinated licensed band, so you have to go to the licensing authority. They will issue you a frequency you can use it on, and that means that you've got a reasonable guarantee that the frequency you're going to be operating on is yours and isn't going to be interfered with. It's not foolproof, but it's a good start. The fourth radio in the lineup is B24. I'm not going to B24. I can show you because they're both set up outside in the garden, so I can show you the interface, but not the radio. It's a smaller antenna. This is an old B series, an old client. They're about so big. It's designed for very short haul, very short distances, maximum of 3K, depending on where you are in the world. We've got some restrictions in Etsy, where we have power restrictions, which brings the distance down. And in the UK, I've got a problem with the amount of frequency that Ofcom let me use, which brings our speed down. The UK have been quite backward with the 24 gigahertz and only give us 100 megahertz of spectrum to use. So I can't use the radio at full capacity. Now, the one thing these radios have in common, despite the fact they're all different frequencies of operation, is the way in which they work. And this dual link is the important part. All of these radios run in 2-channel operation. So you've effectively got 2 radios in one. So two by 2 radios. Each radio runs 2 separate frequencies. It's all a common code base, all a common chipset. So the maximum bandwidth value for each frequency is 80 megahertz. So each one of these can take, in full capacity, up to 160 megahertz of spectrum. This is where I struggle in UK with B24, because if I've only got 100 megahertz of spectrum I can use, I can't use the full 80 mode. But using the full 160 megahertz of spectrum, that gives you a maximum radio rate of around about 1.7 gigabits per second, which when you take it down to IP speed, gives you a maximum payload of around about 1.4. Now we can split that 1.4 equally upstream and downstream, giving you a 700 meg full duplex radio, or you can alter it and bias it in different directions, and I'll go into that a little later on how you can change that. All of these radios have GPS built in. They're all aware of where, they're all aware of where they are in the world. So getting your unlock correct, getting your location and your networks set up correctly is absolutely critical. If you tell them they're in the UK, install them in Germany, they will tell you they're not. They're in the wrong place, and they will shut down until you license them correctly. You can't play games like that. As I mentioned last week, if you're installing close to a country border and you have issues with location, let us know on the chat, let us know on support chat, and we can work our way around it. There are ways and means. All of these radios are designed to be put high up on a tower in the middle of nowhere, so they're all solid, waterproof, weatherproof, IP67 sealed radio units. They're very, very tough radios. So, GPS enabled, dual link for speed, and tough. They're the key takeaways. If you don't need the capacity, we have this. We can use the C series radios in point-to-point mode. So as before, the C5X with its screw-on antennas to give you the distance. If you're just running this across the street or running them over a very short distance, 50, 60 yards, 2 units on their own will work perfectly well. Fit and forget. Your other option is C5C. So you have the ability to bring your own antenna. If the 25 dB is not enough, then put another antenna on. Again, as with the B5C, the B5 connectorized, when you're buying a third-party radio, this is a antenna. This is what you've got to look for. You've got to look for the dual input, dual polarization, because again, you're running this. Although it's in a single frequency, you're running this in two polarizations. So antenna selection is key. And a quality antenna will always give you a better, a better signal, better performance, and a better installation, a more reliable installation. So you can see the difference between the C series and the B series is the speed. Here we're only using a single channel in 2 polarities, so we have 700 meg. In the B series, we're using 2 channels in 2 polarities, so you're doubling your potential throughput. So we have 1.4 meg. So this is your potential IP speed. These radios aren't designed to be mounted right up on towers, 50, 60, 70, 80, 90 meters up in the silly weather. They've been designed as clients, so the weatherproofing isn't quite as extreme as the B series. However, it's IP55 with care and good installation. We'll talk about good installation later on. There's no reason why these you're going to have any problems with water ingress into these. The enclosures are well designed. They're designed to snick up nice and solid, and the ability of a little bit of silicone or a little bit of PTFE tape makes a whole lot of difference. And of course, we're all using good quality, external grade, shielded cables on these, aren't we? That brings the diameter of the cable up slightly, so they sit into these little cutouts nice and snugly and keep the water out. I keep jumping the wrong screen. So we have a portfolio. We have a range of products. We have products that will do short distance stuff. If we just put the little 12 dBi on the C5X and run across the street, easy. We just want to run half a kilometer or something like that, B24, perfect, high capacity. And if you want to go further, then we've got a range of options in 700 meg range and the 1.4 meg range. Sorry, 1.4 gig range. Range of products. It's like Lego. You put different parts together to give you to build yourself a solution for different areas, for different scenarios. But it's all based on the same base. It's built on the same base code. It's also based on a very, very similar interface. So if you have knowledge of one Mimosa radio, if you installed one Mimosa radio, I'm pretty confident that you can install another one. And when you see the interface of the radio, if you're on the call last week, what you'll see is it will look very, very familiar. So just to give you a little bit more detail of the B series radios, this is a breakdown of how it's all put together. A conceptual block diagram, if you like. See, that's what I've got written in my notes here. So data comes in on the Ethernet, it's encoded and modulated. Every radio in the world does that. You need to encode it into a form in which the radio chipset will transmit it. This is the point at which we start getting clever, and in this area here. So we take our radio payload and we split it in 4. Now the way we split it changes depending on how you're running the radio, and again we can talk about that in a wee while. But basically we take our data stream and we chop it up into 4 things, and we split it over 1, 2, 3, 4 radio chains. Chain 1 and chain 2 are going to be transmitted in one radio channel, and we're going to split it. Some of it's going to be transmitted in horizontal and some of it's going to be transmitted in vertical. So half of your data is on channel 1. The other half of your data, again, it's split into horizontal and vertical, and it's shuffled onto channel 2. So again, 2 data streams on channel 2 on another frequency in 2 different polarizations. So 4 transmitters, 4 receivers, 4 streams. If you were to look at a C series in point-to-point mode, you're effectively losing chains 3 and 4 and channel 2. So you're kind of cutting it in half around about there. So it's half the radio, half the capacity, same underlying principles. Clear so far? The other part we've got tied in with this is, again, if you're on the calls last week, you'll know that we run a real-time spectrum analyzer in background all the time on our radios. You can access it yourself. If you go onto the GUI or have a look in the on the cloud, you can take a look and see what the radio spectrum's like. The radios always work in a master-slave relationship. In point-to-multipoint is obviously clients and the access points. In point-to-point, we call it access point and client. It works in exactly the same way. The access point is the master. The access point always takes the decisions. So the clients will send spectrum data back to the AP, back to the master, and the master will run the network. The spectrum analyzer occupies a little bit of airtime, but it's only a tiny, tiny amount. But it's there running all the time. So you can see here, this is a 5 gig radio. It's a 5 gig single channel radio. And we're seeing some red parts here, which is restricted by country of operation. So the radio won't use these. For some reason, whoever set this radio up has put manual exclusions in. So we've got the grey points here, and the green point shows where we're currently operating. And that looks like a 40 megahertz channel to me. You can see here, we've got some interference with a big blob of interference here. And we've got some peaks here, but it's happening less often. If you've got a big peak and it's red, stay away, stay away, stay away. If you don't have any choice, then you can start straying into the purples and blues, but it's always good to try and keep it as low as possible. Aim for space. So that's there, that's running. Now, the nice thing with dual link, I mean, this works really well in B5 because we get a lot of interference in 5 gig. If we took the spectrum, look at the spectrum analyzer running of a B series radio. Again, looking at this would actually be a B5C because it goes from 4.9 to 6.2. It's not a B5. B5 is slightly restricted. But the nice thing about dual link is we're running in 2 frequencies. So here we've got channel 1 and channel 2. So data's being split equally between the 2. There's a little bit of interference coming in, and you know, it's dropping the modulation levels, but the radio's coping. If there's a lot of interference coming in, and you will see here on this animation, we get a big pulse now. If that's consistent and that's giving us issues, and we're losing data because of it, the radios will take a decision and start shutting down receivers. So it will turn a receive channel off and it will switch the data to the other channel. So if the radio is not being fully saturated, rather than losing data, we'll move data across onto the other channel. So it gives us resilience against interference. You've got data security. Okay, it's not running quite as quickly, but you're not losing data. That's the key. And the radio will monitor the airwaves and monitor and see if it's working. And once it sees clear air, it'll start opening channels up. It'll give it 30 seconds or so to ensure that the channels are clear and they're running cleanly. But once that's happened, it will open up and the radio will go back to full capacity. So you can see on this animation, you know, we're running at 1.1. We then get a little bit of interference come down, and the headline rate drops down to I think it's 400 meg. Of course, now I talk, it doesn't change. Always the way. The radio is coping dynamically with the environment. I think it only runs the animation so many times. There we go. As soon as I move something, it changes. So here it's dropping down, it's changing, it's adapting and overcoming the interference. So that gives you a great level of security of connection. The radio will automatically decide what's the most efficient way to run. It will move channels around. It will work. And our auto everything mode works really, really well. So let's take one of these radios from out of the box to getting it operational. First thing we do, we've mentioned it before, we keep on mentioning it. First thing you do, go to the cloud. Download firmware. Make sure the radio is on latest and greatest. Do it in the office before you go anywhere. Don't do it in the field if you're in the middle of nowhere. Download firmware, get your unlock code, get the radio unlocked, get it added to your cloud, power it up, browse the default IP address, and go through. Firmware download, unlock, password, login. And then configure the radio. So what I'm going to do now is I'm going to jump to a live running radio and take you through the interface. Actually, before I do so, I'll show you a little video with the B11 setup. So I'll give my voice a rest for a second, have a drink, and hand you over to Michael.
Hello, and welcome to another episode of Mimosa's in the Field series with me, Dustin Stott. Today we're going to be installing a B11 radio with a Gears 680 dish that's going 14.5 miles away. So we're going to be putting up the dish up there on that very steep and dangerous roof. It's okay, I'll be all right, I promise. And we're going to show you the construction of the dish, we're going to show you mounting it, and we're going to show aligning it with a compass, and using the design tool. While I construct this dish in super speed, let me give you an overview of the B11 radio. It can operate in the 10 gig to 11.7 gig band, with the 10 gig band which is offered in some countries, as well as the 11 gig band, which is the classic long-haul carrier band. Here at Mimosa, since we're an equipment manufacturer and not a service provider, we decided to install this link using experimental licensing in the 10 gig band as a test setup in our alpha network. We run a channel bonded TDD and an FDD channel pair, which is 100% FCC legal. The advantages to this approach over traditional FDD radios are twofold. Number one, we can use our auto mode to adjust the time to maximize the throughput in whichever direction requires more capacity. And number two, by avoiding costly diplexers required in FDD radios, we can offer a solution that is a fraction of the price of the legacy vendors in this space. So now that we have the antenna mounted, we're going to start trying to align it. So we're going to start with our compass, since we pre-planned using the network design tool, so we know our compass heading. We also looked at the maps, we know a general direction it's supposed to point. And then once we get hooked up, we're going to go through the fine-tuning adjustment phase, which you start with either horizontal and vertical, do a pan, you go all the way one direction to where you lose signal, you go all the way to the other direction where you lose signal, and then you kind of home in to the middle where your best signal is. And then you do the same thing with your vertical. You go up as high as you can until you lose signal, then you go down as low as you can until you lose signal, then you come back to the middle here until you have the strongest signal. So your alignment should be about perfect once you get to that point. All right, Eric, so we're currently at neg 71.7. So we did pretty good with the initial mounting of the dish and the alignment via the compass. So now we're going to start adjusting, fine-tuning the dish. We're going to start with moving left, going horizontal. So we're going to go a little bit at a time here. We're going to let the screen refresh. Neg 70.6 is what I currently have. Now it says neg 73.2. So let's go ahead and move back the other direction, to the right now, and try to get this honed in. I see neg 64.3, 60.1. All right, so now I'm at neg 55.7. Let's go ahead and try vertical after you get that tightened up. 48.3 is what it looks like I'm at now. Let's go back down a quarter turn at a time. 45.1, 44.2, 42.9. Yeah, let's go ahead and lock it down. So initially we started out using 2x40 megahertz channels while we were aligning. Once we swapped 2x80 channels, we were able to achieve over a gig of throughput. All right, so now that we have our B11 dish aligned, the link is up and ready to go. Just a quick closer before we end here. Pre-planning is important. So just make sure you use the design tool to model your link before you put it up. And that's it. So we'll catch you next time on our next field video.
It makes it look so easy. To be fair, there are harder radios to install. It really is quite a simple radio to get in and running. They mentioned that you saw a couple of things there. I mean, one was the alignment and the little blue shading on the scale. Because these radios are GPS aware, they know where they are in the world. They know how far away they are from each other. They know what power levels you're transmitting at. So it's very easy for them to do the maths and work out what your target RSL is. So they will give you that little points to aim for. So it gives you a good idea of where you are. When you come to doing the same thing with the C-series radio, remember that C-series, for reasons of cost and complexity, don't have GPS in. So again, give them their location. Let them know where they are in the world, so you've got a good target to aim for. Otherwise, just aim for aim for maximum, try and peak them out. So I'm going to jump to my cloud connection here, and again back here, lovely sunny Formby, just north of the UK, just north of Liverpool, sorry, and you'll see a little change from last week. Here we go. So our link here is showing my normal 4 pieces of equipment. Only this time, my AP and CP are offline because they're on a table in the conservatory, and I've got 2 new radios online and showing alive. So my B24s are up and running. Now I will say that my B24s are very, very poorly aligned. Although they're not very far apart, so they kind of have to be, so we don't get saturation problems. But it's enough to demonstrate. So there's a GPS drift. Yeah, we're not doing too badly. That one's where it is. That one's actually probably closer to there, but close enough for management. So as before, I can click onto a unit. And the dashboard is very similar. These haven't been running very long, so let's take that down to an hour. Over the last hour, you can see the transmit rates. When I first plugged them in, it's jiggled around a bit and come up, and it's settling at 1170 in one direction, 1500 in the other. It's not too bad considering line of sight is compromised. Again, I've still not raised the units high enough so that they don't hit the little wooden structure. And they're very, very close. I wouldn't want these too close because we will get issues. You can see that my power level here for the office one is 52 dBm. With the noise floor, that gives me an SNR of 34.1, so it's running pretty well. As before, with the other products, I can snick through a whole lot of information. The B24 is unusual in that it and the B11 have fiber ports, or can have fiber ports. You can snick a little SFP in there. So if you have a noisy tower, RF noisy tower, you can run fiber to the head to give you a slightly less noisy experience. I've not got fiber in these, so the SFP has not been enabled. So GPS should be there. Happily sitting there on 5. A little bit of errors. MCS rates. Oh yeah, they've steadied down now. They've settled down now. They were a little wiggly to start with, whilst they're learning the environment, and then after about half an hour of being online, they've settled down. So we can see a nice little overview through the cloud management. You can see they were cold when I plugged them in, and they've warmed up to a nice little 45-degree operating temperature now. So there's the management. Spectrum, well, they're in 24 gigahertz. There isn't a whole lot, so I'm not expecting to see anything in here other than what I'm running. So yeah, nothing at all. You can see that these are running in full mode. I'm using a full 160 megahertz of spectrum. It's a temporary installation. They won't be staying there. So because I'm in the same IP range, or I'm on the same network, I can now dive into this radio. So click in onto the back of the radio, onto the management, and password login. Now, whilst we're talking about management, as with the access points last week, All B series radios have a 2.4 gigahertz management radio. So that's true for B24, true for B5C, B5, all of these. So the example that, somebody coming in. The example that that Dustin just showed with the aligning the radios, you don't need to have a laptop up on the roof. If there's the two of you up there, you've got a little 2.4 gigahertz radio. Get the management interface up on your phone and bring the alignment in on your phone. Far easier than carting heavy bits of kit around, or shouting down at your guy on the ground. That's a really, really good use for that little 2.4 gig radio. You've also got the recovery radio on these. So should you forget passwords, should you lock yourself out by playing with VLANs, which I've done on a couple of occasions, excuse me, we've set a management VLAN and locked myself out. When you first power the radio on, you'll see two 2.4 gigahertz networks come up. They're based around the serial numbers. So in this case, for this one, my serial number ends in 582. So I would see a M582 SSID broadcasting, and I would see an R582 SSID broadcasting. The R582 is only active for about 3 minutes and then it's shut down, but that is your way of getting into the radio and doing a factory reset if you've forgotten everything. Incidentally, on C5X, if you need to perform a factory reset, let's see if I can do this. This is difficult to line up. When I've got other things on screen, you'll notice here, oops, on this side, this is really difficult to do. I have a little, you've got two LEDs, my camera's backwards, and there's a small slot in the middle. That's a pin interface. It's got a little R on over the top of it. Should you lock yourself out one of these, obviously there's no 2.4 gig management radio on these. There's no recovery on these. Get a paper clip. Under that little R slot, there is a little micro switch. Doesn't require much pressure. Push the micro switch down in. Power the radio on. Keep it in for about 15 seconds, about 15 Mississippis, and you will reset the radio. Sometimes takes a couple of tries, but get it in. It helps if you have a friend because you need 3 hands. Push it in, hold it in, get somebody to power the radio on. Count to 15 slowly, release, and you should have a factory reset radio. But a lot easier with these. A lot easier. So here we have the radio that's running, and again, as before, the easiest way to configure one of these is work your way down the list. So here we are on the dashboard, and this is just our stats screen. So this is our link. It's called Garden Shed B24. We're connected. It's seeing the satellites, so all the timing is good. You can see as I hover over it, I get a little bit more information. So that's brilliant. That's working. That's up. That's up, and it's happy. Link's been up for an hour and a half, and we're getting 95.973 availability. That'll get better as it comes up. Our signal meter here, well, we've got a target of 15.2 dBm because it knows how close the radios are. Obviously, I'm not going to try and do that because it'll give me issues. And if I go into aiming mode, and again, you can do this through the on your phone up on the rooftop. You can see our little blue area here. So you know, that's where we would be in a real installation. That's where we'd be aiming for. So this is just a little too close. If your signal to noise ratio exceeds neg 30, you will have issues, particularly with B24s. The sweet spot SNR is around about neg 30. That's what you're after for these radios to work to their absolute optimum. If I were to line these up at neg 15.2, I would have reflection problems, I would have interference problems, you would see jitter, you would see the all sorts of issues with the data stream. I've seen on a couple of occasions when people have installed B24s, they've come to me and they've had issues with the data. Backing transmit power off, just a couple of dB to bring it down to that neg 30 sweet spot works absolute wonders. So you can see here they're running a radio rate of 1300, transmit receive 780. I'm happy with that, and said they are intentionally misaligned so that they don't have issues. But you'll see here lots of stats. Look at the performance, look at throughput, look at the performance of the radio. We're not pushing these. There's no real data running over these, so there's nothing there. Management information, names, serial numbers, IP addresses. They're running in station and access point mode. It's all set in automatic. All good. A little bit of information, MAC addresses, Ethernet MACs, all of that. It's there. For deeper analysis of how the radio link's running in a real environment, the MIMO status is really useful. You can see here we've got transmit power and noise on a per chain basis. So the different polarities, the different frequencies. So you can see chain 1, chain 2, as we said, are in one frequency. Chain 3, chain 4, as we said, are in another frequency. And we've got the two different polarities there. So you can actually get a good idea of what's going on by analyzing this. If you've got a link that's underperforming and you believe that it's only running in two-chain operation because of interference, you'll see it here, and you'll be able to see it within this MIMO status. So it's a very powerful little snapshot to see what's going on. Good afternoon, Vadeems. So that's quite a useful status, little status there. And this is true across all B series radios. It's always there. And again, in C series, it's there, but you're only going to see 2 channels because there are only 2 channels. So working our way down, configuring one of these. Channel and power, well, there's our analyzer. We know it's clean. And these are our settings so far. And look at our link. Now, this radio here is set as the station. So these are your options, access point and station. In fact, what I'm going to do is I'm actually going to jump to the other end. It makes more sense to show you the configuration of the access point, because as I mentioned before, the access point is the radio that controls the link. So if I go back to my dashboard, I'm going to jump to the garden shed end, because the garden shed end is controlling this link. So again, log on. Should ask me for password, which it does. Good stuff. So this unit now, if I check the link, is our master. This is our access point. So this time I have control. So this gives me the ability here to change channel width, to change the frequencies. I'm going to change this to dual 40 megahertz operation. I'm going to save the changes. And this will effectively halve my my throughput on this radio. So there we've got our frequencies set. Our link, this is the access point, and we're splitting the traffic. We're splitting the traffic automatically between the two radio channels and the two directions. Now this brings me to an important point. 50-50, 75-25, 50-50, 75-25. 50-50 and 75-25 is fairly self-explanatory. We're sending the data out 50% in one direction, 50% in the other. So we're managing the time slots to 50% of them up, 50% of them down. 75-25 is exactly that. Again, 75% of the data will go in one direction, 25 will go in the other. So you're managing the time slots. But you'll also see A's and B's here. I'll explain those. I'm just going to jump back into the PowerPoint in this direction. This is to do with our TDMA, and this is the TDMA gender. So when you've got an SRS radio, remember SRS is our proprietary TDMA time slot management scheme. SRS runs across all Mimosa products again. This is specifically, or probably more in most use, in 5 gigahertz. So with B5 and B5C. You can set radios up to be a gender of A or B. Now the way we work it is gendered radios transmit at different times. So radio A will always transmit at one time, radio B will always transmit at another. So if you've got radios in the same frequency, in the same 5 gigahertz channel, on the same site, back to back, like we have here, what you want them to do is transmit at the same time. So that this radio transmitting and this radio transmitting are just going to be sending data outwards. You always get a little bit of radio coming in backwards. You always get a little bit of backscatter. And the last thing you want is this radio receiving this radio's data. So always configure your network and always build your network so that A radios are together and B radios are together so that they don't trip over each other. And the same is true when you go back to the point to multipoint. If you've got a B5 point-to-point link, and that B5 point-to-point link is feeding an A5 access point, and you need to use the same channel for both scenarios because of congestion or just because of frequency reuse, make sure your A5 and your B5 are in the same gender, with the same gender. So keep your B's together, keep your A's together. Otherwise, you'll have potentially have interference issues. If you can run different channels for everything, you're a very lucky installer. There are places in the world that like it, but in most areas, we have to compromise. I mentioned the different genders. So in this example, the A are going to be transmitting on the rising edge of the clock pulse. B are going to be transmitting on the falling edge of the clock pulse. So we're using our GPS to shape our framing and ensure that our framing is consistent across the network. So this is built in. There's no extra GPS hardware. There's no extra GPS software. There's no little licenses to do this. This is built into Mimosa as part of the core functionality. You've also got to consider transmit windows. So here we go. So gender A is transmitting and then receiving, 50-50. Gender B is receiving and then transmitting, 50-50. All good. You've got the opportunity to set this 75-25 mode. So you're transmitting for 75% of the time, receiving for 25. So gender A would be at the head end, transmitting internet data down to a client. The client for an internet browsing client is going to be receiving for 75% of the time and transmitting for 25. You send a few commands over, up, you get a lot of data back. I want to watch Top Gun the movie, a whole lot of data coming back. That's the way it works. So this is the gender A, gender B split. In the new software, which the guys are talking about landing over the next couple of weeks now, you'll also have a 2/3, 1/3 split as well. So we'll be able to be a little more granular with this. Or in a B series radio, you put it in auto mode and let it work it out for itself. And that works pretty well too. So this is your 75-25. These, I'm leaving them in auto. This is part of your configuration. Give yourself a nice friendly name. Give it an SSID. I use Mimosa 5G. That's probably all of my neighbours really scared now because they think there's a really horrible 5G system around. Don't even get me started on that. Some of the stuff on Facebook at the moment is astonishing. Set your encryption key up. It's point to point. It's 128-bit AES key, SSID, encryption key, go. Done. So frequency set, encryption keys set, put a nice friendly name on, and the radios are pretty much ready to play. You've got a couple of options here. You can look at the rate adaptation. This is whether you want the radio to be aggressively trying to run the fastest modulation, or in conservative mode and be a little more stable. Again, this is a fine-tuning requirement. The rate adaptation criteria is basically based on PER, so basic error rate, or EVM, error vector magnitude. The difference between the two is basically this is your local error rate, that's your remote error rate. So this is fine-tuning again. In most cases, PER and aggressive, which are the defaults, are fine. Location, you've got nothing to set. It's a point-to-point radio, it's GPS aware, it's going to tell you where it is. It only becomes a problem if you start losing the GPS. Again, we don't often have GPS issues. Sometimes if we're in close proximity to some LTE kit that's on a similar frequency to the GPS satellites, we've seen some interference issues. Always ensure that your radios can see the sky. This radio and B5C and all of them, the GPS antenna is here. It's right in the top of the radio. Now, if you mount this underneath somebody's antenna, right in the shadow, might be a nice neat installation. It could even be your own antenna. Nice neat installation, everybody's happy, except you've got a big chunk of metal above, in between it and the satellites. That could be an issue. Mounting it on the back, inside the tower, could give you an issue. Always leave yourself some space to see the sky. The radios will operate without GPS, but they work better with. The clock chips in these are pretty good. They'll work happily inside, but it's better for the radios if they can see. So as before, and as we've seen in the point to multi-point products, everything else within here is just useful stuff for you to see what's going on. So we have, give it a nice name. Put it so you can see it in your management and it makes sense. Give it a name, give it a description. It's going to work out its date and time from the GPS. You can put an install date in. Again, good management, good visibility, see what's going on. Change your passwords. And if you want to go into stealth mode and hide this, you can turn the LEDs off or turn them down. The LEDs on the B series radios, show you on the B5. Shush, Siri. Power, Ethernet, radio. When you've got the radios connected, they start talking to each other. This will flash. It's a blue light. It's a very, very, very visible, very, very high intensity blue light. If you're doing a stealth installation, you might want to turn these down, but they are very, very bright. It's good. You can see them in decent sunlight. But if you're going to the lengths that some people go to with spraying them with acrylic paints to camouflage them on rooftops so they don't get vandalized, then turning the lights off is sometimes a good idea. What else do we have? Management. Well, you want to be able to see what's going on, so IP addresses for management. It's purely for management, doesn't affect the data at all. So default IP address is .20. My radios are set up so that they're picking up a DHCP address from my router. If they don't, they drop into static. You can change that and just put them static if you need to be. Tell them where the gateway is. DNS and secondary DNS. Why does a point-to-point radio need DNS? Well, for the management. The cloud management is web-based. The radios send status packets blind into the cloud to talk to the Mimosa cloud database hidden somewhere in the dark depths of the Amazon servers. So you're sending a status packet out into Amazon. There's no quality of service. We don't check on this. It just goes out and hopefully it reaches there. So sometimes when you first put a radio on, it'll take a wee while to register in the cloud. Normally within half an hour or so, it's there, but it's very much a best effort sort of thing. If you want proper day-to-day, instant by instant management, then you're going to start looking at SNMP or something like that. So you've got that further down in notifications. Services, always a good idea to put HTTPS on, make these secure. You can change the web ports to make them less easy to find and hack. You can turn management VLANs on. If you're running a management VLAN, put that on so it's separated away from the user data. Watchdog, ping watchdog, you can make it ping a certain address. So you put the address in here, give it the interval, delay after startup. If it fails to ping that address 3 times, it'll reboot the radio. Again, that's something that has been put in as a response to an error. I suspect it's not something you'd be wanting to use on a regular basis. It's purely if you're having issues, it's a good diagnostic. If you've got the, using the SFP, you can turn it on and do things like change the Ethernet speed here, lock it in. If you have particular routers, again, we've seen some issues with some Cisco's in the way that they negotiate. Sometimes it's a good idea to lock the RJ45 speed down. There's a few extra bits and pieces coming in here. Cloud management. If you want to go into stealth mode, if you don't want to see these seen in the cloud, turn it off. Rapid port shutdown, flow controls. If the radio link drops, it'll turn the Ethernet off. It's all within here, and rest management. This is for I think this is because this is a beta. Actually, this is something that's not in the standard in the standard product. Firewall here. I'm not going to do it because it'll reboot the radio. We've had issues in the past. The firewall is designed to stop denial of service attacks on the management. The radios are managed via the web console. It's the only way we can manage these. But if there's a denial of service attack, the firewall will turn this interface off. Now, we've had a couple of issues in the past with certain SNMP management suites being a little over enthusiastic in their polling, shall we say. And the symptom is that the client starts losing network management of their radios. You can troubleshoot it by turning the firewall off. If the problem goes away, you know what the issue is. I'd then look at your SNMP management system and try and decrease its polls a little. There are a couple of them that get a little bit they're a little bit chatty in their walkthroughs of the SNMP trees, and they can sometimes give us issues. Carrying on through. This is our little console network for alignment for management whilst you're hanging off a tower. It's difficult to use a laptop at 100 meters up. A hell of a lot easier to use one of these with the lanyard on. Always useful to have. So you can have it on. You can turn it off. You can put a timeout on. Change the SSID. Change the channel if you're getting interference. And this is your recovery SID. That will never change, but that will never stay on past 3 minutes. You can even encrypt it. By default, it's just an open network. I'd suggest that with the encryption key is probably a really good idea. Notifications is for your management. Again, it's up and running. This doesn't matter to the radio, whether it has SNMP or not. It probably matters to you. You want to see what's going on. So SNMP, enable, and you're away. In the new version of software, you're gonna have SNMP version 3. So that's coming out in a couple of weeks' time. We're still trying to fix a date. Contact, location, trap server. That's the important one. Let the SNMP know we're sending its traps. If you've got a remote syslog, enable it here, put in the address, tell it it's UDP TCP, remote log port, boom, you're away. And choose what you want sent where, whether you want everything sent to SNMP, everything sent to syslog, flexibility to choose what information you want and where. You've probably seen this is very, very similar to what we saw last week, to what we saw with A5. The interface is pretty much the same. Firmware updates. So I'm running an old beta firmware here. To update it, choose file. It opens up a download window. Pick it, and you're away. It'll upload. It'll verify. It'll reset. And you'll be online with the new firmware. When you want new firmware, get it from the Mimosa website. It's in your cloud account. So you'll see here for V24, which is what we're operating. I've got that's the last live one, live version. I've then got some betas I could put on. You may not have these in yours. This is the firmware release is personalized to you. If there is some special software that is pulled together for a particular reason, if you have a problem, you talk to our support people and they do a customized firmware burn to look at a problem or investigate a problem. This is where you'll find it. This is where you will find everything in your managed network firmware in your cloud account. So we can change this. So there's your firmware. Reset and reboot. Factory reset is everything. So that's complete factory reset. It'll unlock it. It'll relock it. It will remove it from your cloud account. It will be as if you never owned the radio in the first place. Reset config will do exactly that. Reset the configuration, but it'll still be unlocked and it'll still be in your cloud. Reset unlock leaves the configuration intact, but you no longer own it. That's a useful one. So if you want to pre-configure a radio, then give it to a customer to put in their own cloud, that's the one you use. Incidentally, if you have if you want to transfer a radio from one cloud account to another, as long as you are a manager in both networks, so you can add different managers into your network or vice versa. You can transfer a radio between. So if you're a reseller, you're doing the configuration, you're doing bench testing for your customer. If you get your technicians added to their network as a manager, which is useful to have sometimes, so you can help them with their diagnosis of any issues in the field. You can transfer from yours into their pre-configured, and everything's good to go. The other way of doing this is backup and restore. So download the configuration. Again, if you've got a lot of radios that you want to configure the same, it's a neat way of doing it. Download, restore. Moving on to diagnostics. A couple of different things. Ping, as before, pick a host, pick a packet count, run test. Trace route, again, as we had with the point to multi-point radios. We've also got a little bandwidth test. So duration of test and which way you want to do it. So local remote, start a test. You see it rapidly ramps up to speed. Runs the test and you're there. You see we're running at 600 meg because I'd last time I looked. We're running 240 megahertz channels because I changed that. So that's all there is to configure one of these. It's very, very simple. For the client end, it's even more so. I mean, all of this stuff is the same. Channel and power, you have no control over because as a client, that's controlled by the access point. That's controlled by the master. So you have, as a client, once you've set yourself to be the client mode, all you can do is scan. So you go into the field. You've already set the AP end up. Sit here in station mode and do a scan. Hopefully you see it. What was the dangerous bit doing this sort of thing live? There we go. Select it. It'll populate this figure here, put in your key, hit return, and you should be connected. Just jump back to the dashboard and wait for it to come online. Once you've done that, go into the alignment mode. So use the aiming mode, and as Justin showed with the B11, it's the same in any product. So bring your horizontal in slowly, go right the way across, so you pick up any side lobes, work out what your peak is. Bring it into peak, then down, then up. I normally do a couple of iterations of each just to be sure. So bring it across, peak, down, up, peak. Once you've done that, get your partner on the other side to go through the same process. So you're slowly but slowly improving, bringing them in. So A side, align, hand over, and it's worth getting a formal procedure in place between your installing engineers. Make sure there's a proper affirmative handover. You have control of the link. There's nothing worse than trying to install the microwave link with both guys trying to pan at the same time. You'll be up there all day chasing your tail. A hand over, hand back, peak again, peak again. If all's gone well, you should be absolutely bob on. You should be absolutely in line. You should be well within the little blue zone there, and everything should be happy. The best installations are always clean, are always well organized, and that's the key. Couple of bits and pieces on around this. Copies of this are going to be available to you if you want to do the latency calculations. There is stuff online. We can make the presentations available to you. There's a lot of extra stuff in this presentation on radio theory and all sorts of bits and pieces that I don't go into. We could make this into a 3-day course. Also, a lot of the screens that I've shown you live are also in this presentation, just hidden away in background, so you can revise. Some of them are a little old, but they're good as an aid memoir. The Mimosa help pages are very handy. I just jump to was a good place to start. Supports.mimosa.co. Firstly, if our support guys are online, I think we're in the handover period between Istanbul and the US at the moment. But you have the chat here, so you can talk to our support guys. If there's nobody online, there you go. You can leave a message, and they'll get back to you when they come on. Oh no, there we go. It was a cookies issue. So that will bring you into the queue, into the support queue, and they'll then help you. So put in your email address. You're away. There's a lot of stuff in here. We group it by product. So there's the access, the point-to-point products. Everything you want to know about a Mimosa point-to-point product is in here. It's searchable. The product specs are all within here, so product by product. There are some FAQs, installation guides, and they will literally step you through bit by bit by bit. We've also got installation videos for some of the products. There's a lot more in terms of video footage on the Mimosa YouTube channel. There's a lot of bits and pieces in there. User guides. If you ever need white papers, application notes, there's interesting stuff in here. And also the documentation on the radios themselves about declarations of conformity and things like that. If you have any trade issues, everything is in here. If you're moving into new territories, you're moving into areas that where we've not operated before, and you need to work things like type approval, then talk to us. I've got all of the radio test results and everything like that in the Dropbox file, which I can share for regulatory approvals. So it's all within here. If it's not in here, I've got it, or I know a man that has. Dustin's a very good source. Lastly, installation. Very little to say about installation on these radios. We don't make it difficult. Tooling required, nothing enormously specialized. Wrenches, please go buy proper spanners. I hate these adjustable wrenches. I own one, I think, and everything else is proper spanners. They make an awful lot less mess. Screwdrivers, wire cutters, your Ethernet termination kit. One of these is only a couple of dollars, but it could save you a fortune in time. Always worth having. In terms of the radios, the B5, 4 little threaded bolts on the back of here that takes a plate like so, which gives you the mounting and adjustment plate. Not got these built up, but 4 Allen bolts brings you a nice solid connection. So you've got an elevation adjustment, which is a slot here, and azimuth is just you spinning around the pole. Grounding, very important. If you're up a tower, just in case you get a hit, we supply ground. There are grounding lugs on everything. So on the B5, it's on the bracket. On B5C, it's here on the back of the unit. Everything. I can't stress more. It's good practice to ground everything. Maximum length of grounding about 1 meter. Put it on something solid. Put it on the structure. Ground it to a grounding rail or something on the structure. So once you've done it, it should be nice. It should be neat, and it should be grounded, which that isn't. I keep saying this with all of our product shots. We never ground them in the product shots, which never works for me when I'm doing these courses. B5C is the Jubilee clips. So again, clip goes through the back here. The clips we supply, just so you're aware, are 25 to 64 mil. So if you've got bigger poles on your tower, you may need to source some more clips. So maximum 24 mil diameter on these. So just something to be wary of. Of course, you've all done a site survey, so you know what you're up against before you come out on site. So there aren't any surprises, because everybody does good site surveys, don't they? Nobody ever wings it. For cable connections, so we mentioned this before, this is the B5C, so we've got our Ethernet in the center, and we've got 2 antenna connections. They're labeled horizontal and vertical. To be honest, it really doesn't matter which is horizontal, which is vertical, as long as, let's see if I can get rid of that. So it doesn't really matter with the horizontal or vertical, as long as they match end to end. So in the case of this, we've got V, we've got H, HV, HV. Back to our Gyrus antenna. They're not actually labelled as horizontal and vertical, although you could say that was vertical and that was horizontal, because it's going to mount like so. It doesn't matter. It's chain 1, it's chain 2. What you've got to ensure is that they match end to end. If you get an unexplained, really bad SNR, you think you've got them, you've got them peaked, you've got a signal, you've got them peaked, you're pretty damn sure you've got them lined up end to end, but the signal to noise ratios are rubbish. Always double check the polarization connections. It's so easy, particularly when you've got lots of cables all over the place, when you're using N-type connectors, to get them crossed up, and before you know where you are, you've got a bad connection. So it's worth keeping an eye on that one. When you've got it up and running, it should look nice and neat like so. You'll see this unit here. We've mounted it at the rear of the pole rather than underneath the dish. To be honest, that's probably the better solution. Remember, keep the sky nice and clear. Keep the top of the radio nice and clear, so it can see the sky, so you can get that GPS connection. B11 or B11, you're not mounting the radio on pole. You're mounting the radio on the dish itself. So the certified the dishes we've got certified for use with B11 have the correct mounting pattern. You're slipping it on, you're bolting it down, the radio is solid and connected, and the alignment is down to the hardware on the dish itself. As before, earthing is key. Get your earthing in there up on the tower. Gland installation on all of them is the same. This locks in with a half turn and comes off. And this is the same no matter what radio it is. So it goes on, locks in with a half turn. Inside you have outer crush gland, center section, which is split, and a little ring to ensure everything goes in nice and cleanly. Give me a second. Random messages. So that's your glanding. On the fiber enabled units, there's another gland which has the ability to take a conduit. So your fiber is not going to be running up the outside world on its own. It's generally going to be the conduit. So we have another little gland like so that will take flexible conduit. It's just a variation of the same thing. We'll give you a nice, solid, waterproof connection, which is what we want on one of these, on a product like this. Put that back together so I don't lose it. So as before, showing the finished article, nice, neat installation picture, and always remember to take your spanners off when you're finished. You'd be surprised the amount of spanners I've discovered up towers over the years. You can see the engineer installing here is staring at his phone. Hopefully he's aligning and not taking a call from somebody. So that looks like an alignment. For the C series products, well, we covered this last week, but just as it's here, mount using the hose clips. Always waterproof. same as in everything else, mastic, and then electrical PVC over the top as a security measure. Always ground, so we give you a nice little tag here to remind you. Best practice is all the way down, but if you can, if you've got to bounce ground to structure, ground to structure. We give you some little dielectric silicone to help. We provide it. Why not use it? So C5C should look like so, nicely installed and in. You can see this one's actually using a twist port adapter where it just clips in. You know, other options could be if you've got RPSMA fly leads to N-type for other antennas. Depends on what antenna you have. B24 is a little unusual in that it has a different method of moving around. We've actually got an adjustment hardware specifically designed for B24. Your course alignment, the mounting is via the ubiquitous hose clips. So your rough alignment should be done swiveling it around the pole. Once you've got there or thereabouts, and I suspect when you've got a signal to start with, when you've got a lock, screw those down, get them nice and tight, and get ready to align properly. You've got some fine adjustment here. The thing with the B24 is the beam is very, very narrow. It's a very, very, very tight beam in 24 gigahertz. So you need a certain amount of dexterity and some very, very careful alignment to bring this in. So we give you an elevation adjustment on this, and it's in simple terms. There's your pivot point. There's your movement point. So slacken that off a little. Don't go too mad. We get a lot of questions about the B24 adjustment, and I think if people are overly forceful with it, then they have issues. If you undo the elevation lock a lot, and there's a lot of slack in there, when you start doing everything back up, you'll get movement in there again, and the radios will go out of alignment. So it's very much a case of just undo it enough just so it will just move. Undo LE lock 2, so again you can just move, and gently bring the elevation in using a Allen key in there. Small movements, small movements, small movements. Then lock these two guys down. Don't hang from it. Just lock them down before you start moving the azimuth. So always do unlock, lock, move, unlock, move, lock, move the other adjustment. Again with this, there's your pivot point, and this is it, and this is your adjustment. So just gently bring it in. For a really good illustration on how to do it, go to the YouTube channel. There's Dustin did a video on how to do it. It's a really good illustration of how to do it. Some of our distributors also have an alternate way of attaching this, alternate system for alignment based on a GRS bracket. But the B24 adjustment is fine. You just need to be a little mechanically sympathetic, I think, is probably the way. But have a look at Justin's. We've already covered this, the fiber gland. Bear in mind that we haven't as yet found a way of doing power over light. Would be really nice if we could, but we can't do it just yet. So at this moment in time, you're still going to need to run Cat5 to power the radio. And when you're installed, it should look nice and neat, like so. And you see on this one, yes, Wonderful. We've actually grounded this one. Lastly, C5X. Again, we've covered this, but just in case you weren't here last week, mounting is with these little fellas, same ones. So 24 to 64. We do have the mounts available. We do have the flexi mounts available to if you need to put some tilt into these, because a standard it's just going to mount straight to the pole. So always remember, you may need a little bit of extra hardware if you've got a massive elevation change between the two ends. Antenna installation. That's the great thing with the C5X. Mount it, put it on, screw it in, done. Get to site, there's an issue, it's the wrong antenna, take it off, put another one on. Easy. No going back, no reinstalls, or no revisits, because you can just go back to the truck and change that antenna out. When it comes to locking it down, here's the little screw. There are a couple of variants I've seen. This one is flat, which I think is current. Some of the older ones had Allen key, so worth checking just to be sure. It's a very small screw. If you have very big hands and you're very, very strong, don't use all of the force on it. You can break it if you're a little too manly with it. Also, please ensure that it's screwed out before you start changing. If you had another antenna on it, we've had a couple of RMAs when people haven't, and they've messed up the thread. The screw's steel. The thread on the radios is aluminium. It scores it up and makes a bit of a mess. So a little mechanical sympathy. Be a little careful, and don't use your most macho engineers to do that bit. Get them to back off a little. Grounding, again, there's a stud on the back. Take it to ground. Take it to one of our little junction boxes if you want. We call it a NID, network interface device. But get the ground in there. Keep the radio safe. We've said before, you've got a couple of options on antennas. So you've got the 12, 16, 20, and 25. And when it's all installed, it should look something like that. Again, we've forgotten to earth these. We keep doing this. But a good installation is a neat installation. If it looks right, it probably is right. And that's about it. Thank you very much for your attention. I enjoy doing these, and it's nice to have an attentive audience. It's been a very strange experience to start with, talking into my computer when I'm getting used to it. If you've got any questions, my contact details are here. Please feel free to drop me an email.